is like debug input outputs. So the IJ tag pads involved logic are being sent to the descent tab using the JTAG signals, and so like uh, IJ like these IJ tags like they basically are the interface to the functional blocks. So like which involve BISR controller, scan mux controller, BS scans, and even IS1687 logic as well, and which are again being controlled by the UTAG networks. Uh, so in order to have a DFT solution that can be like like used again and again for multiple designs, we this CDFT is being introduced in such a way that CDST basically stands for uh, Central Design for Test. So the main component of this block is the PTAP controller. So PTAP controller is like the CPU of this particular entire architecture, infrastructure. Sorry. So this is regarding the tab access infrastructure. Going forward, the tab hierarchy and multiplexing. So basically, what this speaks of is that the this is a Tessent tabs which is being involved here. So it basically speaks about TTP and LTAP interfacing. So how TTAP and LTAP is being involved in these JPads. It acts as a like basically a sole master for the ETAP network that sits under this particular tab as well. So this particular LTAP enables the testing of the external DRAMs by interfacing with the on-chip HBM controller which has been involved here, and which are accessible through again IEEE 1500 protocols, which has been highlighted in the title of this paper as well. So and Tessen tab here is being involved again being controlled by the scan mux here as well. So basically a scan mux uh, involves one of the SoC top level modules. Also there are a lot of ETAPs being involved. So these ETAPs data which is being sent to the scan mux, the same data like one of these data is also being sent to the Tessen tabs, which will again be interchanged between the switch logic protocols of the SoC, and also involving the JTAG pads. So next we are going to talk about the typical IJTAG networks with the SIB. So like this basically comes into the picture wherein HBM DRAM testing is being involved. So we receive the HBM DRAM dice as known as the good dice from the memory vendor. So uh, like ICL, which basically stands for Instrument Connectivity Languages, uh, is one of the key. It plays one of the major role in this JTAG networks connectivity of the typical JTAG networks. So like these are the SIBs and this is the TRDs. So when an instrument is being interfaced with a particular network associated to this, uh, it basically involves the SI as well as the SO signals, which is being coming from the taps. So on receiving these particular signals, the SO signal is being again passed to the SIBs, and then again SIB passes again to the next block. So once all of these signals are being involved together, again it is sent back to the tap. So this tap, uh, there is a signal which we are receiving as well as getting back for the feedback here as well. So like this is about typical IJ time network. Going forward, reset pulse generation to switch between TTAP and PTAP. So like this is one of the problem which we needed to solve while switching the chip IO ports from PPAP and basically TPAP. Like switching from this particular IO to this particular IO was a major problem, and there were constraints with the non-TESN tools and methodologies in the flow as well. So this shows the location of the added logic between TPAP and PTAP protocols. So uh, like if we see this particular tab hierarchy, it shows that it had a higher abstraction level. So compared to this part, so this was very high abstraction level. So the success of this particular hierarchy is being used over here. So like even when CDFT for tab this is also being involved, this was changed in such a way that TPAP as well as JTAG pins were interfaced in the system on chip such a way that the interchange between these two TTAP and PTAPs were associated in a very like a proper way. So using these tools, introspection and the netlist editing capabilities are also being done. So this was about the reset pulse generation. So going forward, IJ tag based pattern generation. So uh, we looked at the hardware side of the DFT access networks and interface solutions. So here we are going to look at the pattern generation aspects. So to use a IJ tag implementation, each hardware component needs to be described properly. So like when ICL is being involved, ICL which basically stands for Instrument Connectivity Language. So when each hardware components needs to be described in a particular ICL, else it will cause a major problem in the defining like algorithms in the AI part of the SoC. So with Descent, the IGTech network connects all these IPs and does not need to be described manually through all of these protocols. And also once like even SDIL or PDL or Verilog test benches, etc., comes into the picture. This is an easy specifications where IPs are being involved. So once the ICL description for a different level of hierarchies, like level of hierarchies for the design is computed, patterns are generated using IJTAG's PDL as well. So post silicon bring up. So effort, like what are the efforts and the benefits of these, we talk about this in this particular column. So basically with the with the flexible switching access mechanism between PTAP TTAP tabs and the IEEE standards for 1687150 networks, we only needed to develop one universal test configuration patterns based on the ICA. So this pattern was used for both testing on ATEs as well as the lab diagnosis. So basically, this approach reduced the efforts, and all of those errors which are being involved, they significantly there were a lot of errors being like this approach reduced efforts. An error-prone process significantly of porting patterns needed for involving the debugging scenarios. So also it involves the patterns formats for accelerations of the pre-silicon pattern verifications. Also smoothened the entire post-silicon process which is being involved in the AI SoCs. And after the DFT task is divided into two parts. Uh, Bring up of the ATPG BIST and ring oscillator tests, which took about 4 days, and like another test which was spent on the other components includes SERDES as well as HBM physical AC/DC loop back test, which involved 8 days. So this also played a massive difference in the number of processing periods which are being involved. So what we can conclude is that the TFT for AI chips, we have shared most of the algorithms which are being involved. So we used a hierarchical multi-tap architectures which can be maintained by using the benefits of using private PTAPs for some of the test scenarios. It also can take the advantage of IJ tags in manufacturing testing. Then also for ETAPs or HBM testing, uh, we spoke about all of those. So the chosen IJ tags based unifying methodologies improve the TFT process considerably, automating the pattern generations and validation processes for all the relevant components of the SoC. So we also benefited from this methodologies, allowing up a very a fast bring up of the first silicon being involved. So that's all about uh, fast bring up of an AI SoC through some of the IEEE patterns which have been. Thank you so much.